As Carl mentioned earlier, the Kwame Planetarium has not yet opened, but I wanted to share with you a little bit of one of the aspects of the new planetarium where we put in a digital spatial surround sound system. So I'm going to kind of break it up into two little pieces here. Why did we decide to put in a digital audio system? And for those of you who are familiar with the old style of analog audio, wires ran everywhere. You needed to run analog cabling wherever you wanted to have any kind of audio. And one of the problems is that analog audio does suffer from interference. And I'm not going to read everything on the presentation here, but you'll be able to download it later. I'm just going to give you kind of a high level overview in my 10 minutes. And digital audio initially didn't have this speed in order to handle the type of audio we'd like to do in a planetarium setting, and indeed in other settings as well, like recording studios. But digital audio has come a long way, primarily because digital networks, data networks, have gotten faster and faster. So now you can get rid of the interference problems of having analog wiring, but also you're able to now replace all that analog wiring. And in many cases, you can reduce the amount of wire because you can run digital audio over standard Ethernet cables. So we decided for the new planetarium that, in fact, that's what we wanted to do, was to do standard Ethernet cables for everything. Now, that kind of explains a little bit about why we went digital, but I wanted to talk a little bit about why we went to a spatial system. George Lucas, who I'm sure everybody's familiar with, is famous for telling us that sound is a really, really big part of any production. And one of the things that has come out of the study of how humans listen to sound is that being able to hear sound not just in the horizontal plane, but all around you is crucial for your listening to an acoustic space. So one of the goals of the planetarium when we went to build it was to see if we could practically do a spatial sound system. I wanted to make a distinction here between what's known as surround sound and immersive sound. Surround sound, which a lot of people are familiar with because it's been around for a bit now. There are lots of home systems being sold. You'll hear people talking about 5.1, which means 5 channels of sound, and the 0.1 represents a subwoofer that's added to bring in the low and the bass. There's 7.1, and there's even higher, although most of you probably won't be doing that in your home. But the surround sound exists only in a horizontal plane. Now, there are ways to combine surround sound with overhead speakers, but if you just have overhead speakers and surround, you don't necessarily get a full three-dimensional auditory experience. So when we talk about immersive sound or 3D audio, we're trying to talk about sound that's coming from all around you. Now, I know the beginning of this presentation is a little technical, but for those of you who are going to go down this road, you're going to run into some terminology about channel-based versus object-based sound. So in channel-based sound, there are many sound elements. They're usually recorded as individual elements, perhaps brought together, but eventually they're mixed down to what's called an audio track. And then the track may be, again, assigned what we call a channel. So earlier, for example, when I talked about a 5.1 audio system, what I meant was there were 5 channels, and then the 0.1 once again was the subwoofer, but that would be a channel-based system. 5 channels usually in front of you, left, center, and right, and then 2 behind you, a rear left and a rear right. So the thing about channel-based systems is they generally assume that you have a specific speaker arrangement. And then when the person's making the audio soundtrack, they have to mix the sound for that particular arrangement of speakers. And they have to do a lot of machinations to get the sound to appear in a particular place in that sound space. Now, object-based sound works a little differently. The idea is that now that we have computers which can do a lot of digital signal processing, we have a sound that's basically considered an object, but there is, along with the sound itself, there's what's known as metadata. And metadata is a fancy term for saying there is data which describes the sound. And in general, what that metadata is going to do in this case is tell you where that sound is positioned in a three-dimensional field. So if you have surround speakers around you, the object can be placed anywhere in the sound field, and where it's placed is done by telling it where it should be in the form of that metadata. Now, the amazing thing about the metadata is it can be updated over time. So for instance, if you're doing a movie and you have a movie, say 30 frames per second or 24 frames per second, whatever standard you're using, you can actually change the metadata for every frame, which means that you can program a sound to move through the sound field frame by frame if you wanted to. So obviously, having an object-based sound system means you can do a lot more with sound than you can with a simple channel-based system. Okay, so now that you've got the background, I wanted to talk a little bit about spatial audio systems specifically for planetarium domes. And it turns out there is not really a lot of selection. There are a couple things that you want to remember as you're doing spatial audio for a dome. And that is that unlike channel-based sound, you really would like, I think, to use an object-based sound because this allows you more flexibility in how you do the sound in your sound space. And I want to remind you that unlike channel-based sound, the nice thing about object-based sound is since the metadata is with the object, you don't have to mix it for a particular arrangement, a particular set of speakers. But later on, when you install your spatial audio system, your metadata will move the sound around in your particular theater because the objects know the relative place they need to be relative to each other in the sound space. So this is the whole advantage of doing object-based audio. Okay, so what do you need to do spatial audio? Well, you need a sound processor which is capable of taking the sound data and the metadata and synthesizing it into a sound field. Now that just gets you playback. And the other thing that I think all of us are interested in is how do we make the sound for our own productions in our spatial theaters? And what folks are generally doing these days is using digital audio workstations. This has become the norm for editing audio because it's non-destructive editing. You can, rather than cut and splice tape the way it was done ages ago, everything's in the computer and you can cut and paste, so to speak, or cut and splice, but you can undo things. You can try different things out. There's a lot of processing power in digital audio workstations, which also allow you to do all sorts of special effects on the sound. But for doing spatial sound, you need a digital audio workstation that actually allows you to mix sound in a 3D format. And that's actually a big trick. So let me move on and say that when I was doing our research for our sound system, there were only a few choices out there, and I've basically listed them right here for you. At the time, one of our vendors was working with Dolby to come up with a Dolby Atmos system specifically for planetarium domes. Most domes probably wouldn't want to put in the standard theater system because it might require too many speakers, but also it was set for a rectangular room, and obviously we work in non-rectangular rooms. It turns out, though, that that never really made it to market as a product. Another company based in Europe was a company called Eosono, and they had a product available for domes. And it had both parts that I was looking for, the processor part and the part for the digital audio workstation. Those of us in the planetarium biz are familiar with Morrow Sound. He's been a member of the planetarium community for some time. He also has a 3D system, and it's been installed in various venues, and including, I should say, planetariums. But then as I was looking around for examples of installed systems, what I essentially found is a lot of people went and did custom systems. Now, I didn't want to do a custom system. My planetarium has a staff of one, and you're looking at him right now. And I needed a more off-the-shelf system. Initially, the Dolby Atmos system was the one that I was very interested in because I thought it would have the biggest compatibility with soundtracks that might be emerging. But as I said, it never made it to market. The nice thing about the Eosono system, and that's the one we chose, is that we were able to get an off-the-shelf processor, but more importantly, they have a plug-in for an existing digital audio workstation software. And once we have that plug-in, we can design our audio for our own systems. Okay, so here's a quick look at our Planetarium Theater. Obviously, I can't show you the whole dome at once. We ended up putting in 3 rings of speakers. You can see the bottom ring. There are 12 speakers that go all the way around. You'll see a couple arrows pointing to the ring above, where there was another 12 speakers, a third ring of 5, and one at the zenith, for a total of 30 speakers to do our sound field. All right, so a couple parting comments. Our system is not entirely digital. If you're going to use microphones, and we set up some microphone inputs at the front of the room, you're going to need to run analog wire to a analog to digital converter. The other big problem we ran into is if we want to use existing soundtracks, most of the sound processors that can decode 5.1 surround, 7.1 surround, Atmos, Oro 3D, they are not available to digital output. So in fact, we had to get a high-end decoder. We had to put the digital sound into it, but the sound came out as analog, and then we'd have to convert it back into digital one more time so that we could get it into our digital system. And then finally, of course, at the end, you have to turn it back into analog when you're taking the digital signal, sending it to the speakers, and of course, reproducing the sound. Okay, I think I made it right on time here with about a minute to spare. Any questions? Actually, I have more than a minute to spare because I'm looking at the schedule, and the next talk is at 9:45, so I went a bit fast. Please, can you unmute, Steve, or do I have to do that for you? Go ahead.
Just curious if there is any sort of feedback or data from Full Dome show producers as to have there been any discussions, or are they willing to embrace this new type of audio, given that it strays kind of far from the norm? Because you mentioned that the traditional formats are what are prevalent out there right now. So any sort of indications about that? Could you hear me?
Definitely heard you. I'm just waiting for other vendors to unmute and chime on in, since your question was more for vendors.
Well, actually, I think it's for planetarians too. If they're considering something like this, that want to know about availability for shows that are geared to this.
Well, I would say right now there are, of course, not too many shows that are using non-standard, shall we say, spatial surround audio. Obviously, there's a commitment on the part of doing a show, right, that you have to make a soundtrack for it, and most folks I think, are sticking to the surround sound formats for now. The 5.1, 7.1, and those are probably the easiest for folks to reproduce in their theaters.
Okay.
However, I do know there's been a lot of talk. There is the 3D immersive audio group within IPS, and time will tell. Time will tell.
Okay.
I'll say
Thank
for
you.
my institution, we have a commercial audio program. I don't have the bandwidth to teach all my astronomy classes and do planetarium productions, but I'm going to be leaning heavily on the commercial music production folks on campus, basically saying, wouldn't you like to produce in this type of an environment? And hopefully they're all going to say, yeah, this is really cool. And we'll be getting them to not only do experimental audio in the planetarium space, but hopefully some audio tracks for productions that I'm going to be leaning on our animation department to help me out with once again.
Okay. Thanks,
Benjamin, I'm a little confused, but I think Andy had a question in the
Yeah, I'm looking
river.
at that now. What's the learning curve for editing? Well, Andy, I'm at the beginning of that learning curve. And I would say it's pretty steep as you have to learn how to use a particular digital audio workstation software. There's a learning curve just for that. For example, in classes I've used previously, I've used Logic, but the plugin for our Eosono system uses a digital audio workstation software called Nuendo. So I am now at the beginning of a learning curve on figuring out how to use Nuendo. All digital audio workstation softwares are similar, but of course, they're all a little different as well. And then once I'm kind of more familiar with the digital audio workstation software itself, then I need to learn how to use the plugin within it, specifically to move around the sound objects. So I've had 1 day of training so far. They're going to come back after the system's more fully installed and do a few more days of training, and hopefully that'll get us a little bit further up the curve. So I blasted through that presentation because I thought I had to get through a lot more quickly. I did have a couple other slides, which I wasn't going to show, but I guess I could since I have a couple extra moments here. You do have to decide if you're doing a digital audio network, what protocol you're going to use in your digital audio network. These are not the only two. CobraNet was the first. Dante right now seems to be the most popular. There's another which is more of a protocol. And the thing about Dante is that it's not an open protocol in the sense that it's owned by a company called Audinate, but many folks have decided to adopt it, and they're building Dante compatibility into their audio devices. But if you wanted to look for a third one, AVB is probably the next most popular. One of the things that I did run into, though, is when we were choosing our interfaces, our digital to analog and analog to digital interfaces, some of them have their own proprietary network. You'll see in a lot of planetariums London Blue hardware, and they have their own proprietary audio network. So then we had to get one of their products, which would move from their proprietary network to the Dante network. So you end up getting a few additional boxes in your audio system to translate from one protocol to another. I had a big slide on latency because that was the original problem with digital audio networks. Every time the electrical signal had to pass through some kind of box, the signal might slow down, but because electronics have gotten faster, that's no longer the big issue. As you can see, there are a lot of ways.
Are you showing a slide? Are you showing a slide?
Oh, I'm sorry, guys. I forgot to hit my space bar. Thank you for that, Alan. The way these systems make the audio appear in your sound space, there are a lot of different ways of doing it. And I can just jump to the chase here and say our system uses what's known as wave field synthesis. So as you go into spatial audio, you can get pretty deep into various methods of doing audio and how they're moving it around in sound fields. This was just a picture of the our router, or actually our switch. So we set up a separate, what they call audio over IP network. You can have one IP network for all of your stuff, but we decided to have a separate audio only one, so additional traffic wouldn't affect the quality of the audio. These are the 30 surround speakers we used. They're a cinema surround speaker that we placed in the 3 rings plus the Zenith. And then what I'm not showing here, of course, is we had 2 additional subwoofers.
Toshi's
Okay.
asking a question. Is there any ability to manipulate sound in real time, or is it all pre-recorded sound playback?
So some systems do allow you to manipulate the sound in real time. In fact, you can even get a joystick interface. The trick, of course, is if you have a lot of sound objects, how do you manipulate multiple sound objects at once? So it can be done, but I think most people tend to limit the number of objects that they're going to move around in real time. The other aspect of that is your audio processor has to have enough digital signal processing power, CPU power, if you will, to do that in real time. So right now, I'm not planning on doing, I just want to learn how to play with sound objects in a sound field, and the moving it around in real time will probably come later. One of the things I noticed, there was an experimental audio group at the Denver Museum of Natural History, or is it Science? And they had set up their sound system so that in addition to being able to run all their regular programs, an experimental audio group could come in and patch into their sound system to do some experimental audio effects. So one of the things I did in our system here to allow for that as well is we have a lot of patch bays where we can get direct connections to the amplifiers to each individual speaker if we want to start doing some fancy experimental sound as well. Just trying to create a system with a lot of flexibility, hopefully turn the students loose on it and see how creative they can be. Okay, let's see. Denver Museum of Nature and Science. Thank you. DMNS. Thanks, Corey.
You know, when we were making up the schedule for the conference, we were figuring that there would be kind of little breaks between talks, so people can chat. Actually, I don't really mean chat. I mean actually speak. You can unmute and talk about other subjects or about what Benjamin was talking about.
So I'm just
or just take a break.
Or just take a break, yes. So our next speaker is scheduled for 9:45. That'll be Kenneth Brandt talking about, well, his title is episode 49 of the Robeson Planetarium's Rising Phoenix. So I think we'll get a little bit of an update on how his planetarium is reemerging from its travails. But if you want to unmute and chat a bit, that's fine. If you want to continue chatting in the on the river, that's fine too. And I'll be just standing by as well if there are any more questions.
There's Michael has a question. Is there any standardization within IPS regarding audio formatting for system software like this?
I would say presently, no. I sat in on some early meetings when they were just trying to decide on file formats, file naming formats for surround. And I know that that alone was hard to get a lot of vendors to agree upon. Since I don't do full dome production, I don't know if there are some production folks out there who want to chime in, but I don't think most vendors have gone the spatial audio route quite yet.
So I think I'll just ask a question here audially. make it easier. I noticed you're doing a lot of transferring from digital to analog and analog back to digital and back and forth. And I guess that's the state of the art right now and what you need to do. But I was wondering if it looked like in the future that could be simplified a little bit. I think the idea of you having lots of patch bays and flexibility that way is a great idea. We tried to do that at De Anza as well. So what do you think? Do you think it's just because this is so new, there's just, you know, these things will be simplified as time goes on?
I would say that one could start eliminating some of the analog wiring already. For example, they do have microphones now, which put the signal right into the digital environment. And in fact, our wireless microphones do that. They go, the output of the wireless microphone receiver goes right onto the Dante network we're using. But I know that a lot of musicians still have their own microphones, and vocalists, they get really used to their microphone. So for right now, we want the ability to take those analog signals into the system. And then, of course, as I said, the surround decoding, I'm hoping someone will eventually come out with a decoder which stays entirely in the digital realm. And that would save a couple steps from going from digital to analog and back.
That was, yeah, the kind of thing I was thinking about.
That was the biggest hassle in the project, is when we realized that there was no off-the-shelf product for doing that, a digital decoder, so to speak.
And this is a quick question. What's the cost premium for your system?
That's a good question. I guess it added in my mind about $20,000 to the cost of just a standard surround system. The cinema speakers actually weren't that expensive. I think a pair of them was $500. And at one point I was looking to save money by even having fewer speakers, but then I realized it would make the sound field harder to work with. And I was maybe only saving, a couple $1,000s on speakers. So we ended up putting that back in the budget. The big expense, of course, is the surround processor and the labor to put it all in. And I can't really break out the labor costs because it was part of the overall Planetarium AV package installation. And then the Eosono processor, we had started speaking with the folks a year or two ago, and we said, we're an educational institution. If we buy it at your full retail, like you sell it to Disney, we can't afford it. And they were willing to work with us on price.
I don't know if you can hear me. Benjamin,
Jack.
thank you for researching this kind of thing. It's great because as an old planetarian, back in the days of, just barely stereo was pretty amazing. In fact, when I got to Mueller Planetarium in Lincoln, I found that there was a speaker. It was up at the top of the dome, and they had sort of clothed over it. But whoever had put it in there had the crossover unit was actually up at the top next to the speaker. So they ran separate wires all the way up from the crossover, the crossover was underneath the console. So they ran it totally back separately up there. It was weird, and I got rid of it as soon as I could. I'm in Norfolk, Nebraska, the home of Johnny Carson, because I'm on the road headed to Nebraska Star Party, and I wanted to let you know I was listening and enjoying, because up here, the only radio you get, as they say, they got both kinds, country and Western, and some sort of religious broadcasts. And I think the successors to Rush Limbaugh, I would far rather listen to Benjamin. But I'm going to go back to mute now.
Okay,
and,
very good.
Keep listening, and I'll be in Valentine, hopefully in plenty of time for my presentation.
Awesome. Okay, well, let me, you ran a little over into Kenneth's time here. So let me just say in closing, I'm certainly not an audio expert, but I'm a lot more of one than I used to be.